Good afternoon, my dear friends. Once again, welcome to this new session of physics today. So, in the last lecture, we have completed the discussion on the topics regarding the motion of an object on a straight line, where we have discussed about the concepts of motion, the various laws of motion, and then we have practiced certain numericals based on the concept of the equations of motion and related with the motion. Now, dear friends, we all know that those physical quantities that we are talking about from the beginning itself, now these physical quantities can be classified into the two important categories, out of which the first is called the scalar quantities. The scalar quantities. Now, my dear friend, these are the quantities which have only magnitude for their explanation. That means these quantities can be completely classified, can be completely defined with their magnitude, yani value alone. And there is no need to express or explain or talk about the direction of these quantities. Without direction also they are very, you can say, clearly described. For example, when I say that the time is 5 o'clock, when I say the time is 5 o'clock, 5 o'clock is 5 o'clock. It is clear. 5 o'clock in the east or 5 o'clock in the west, there is no need of direction. Similarly, when I talk about, let us say, the distance, when I say 5 kilometers, 5 kilometers is 5 kilometers. A piece of cloth 5 meter long, that is 5 meter long. So these are certain quantities which are scalar and which do not need any concept of the presence of direction, only magnitude is sufficient. But there is another type of quantity which is called the vector quantity, and you can very well understand that vector quantities are those quantities that can be explained completely, or that can be defined completely only when we have both the magnitudes as well as the direction. Without it, we cannot express them clearly. For example, when I talk about a quantity which is like, let us say, force. From the definition of force itself, you can easily know that the force is a push or a pull. Now, when I say push, I am talking about direction. When I say pull, my dear friends, again I am talking about direction. So when I say only that suppose a force of 5 Newton is applied on a body, now this does not clarifies that whether this force of 5 Newton which is applied on a body is a push or a pull. So it needs that clarification of the direction also, and that is the reason why a force is a vector quantity. Similarly, when I talk about the quantity like displacement, when I talk about the quantity like displacement, displacement also involves the direction because it is the distance between the initial and the final. So we need the direction of final position and the initial position. So it is again a vector quantity. Is it clear? So I hope in these 5 minutes I am able to make you understand what are the scalar quantities and what are the vector quantities. Now see, my dear friends, when we are talking about the concept of scalar quantities and vector quantities, obviously this is physics, and in physics we sometimes have to add different quantities together. Sometimes we have to multiply the different quantities, sometimes we have to divide, sometimes we have to subtract. That means basic algebraic you can say operations we have to perform. Now, because scalar does not involve any direction, so it is easy to apply those general operations of mathematics in scalar quantities. But if the quantities are vector quantities, then simple operations of mathematics cannot be performed here because vector quantities involves the direction. Is it clear? So next we are going to discuss about what are the different types of vectors. Different types of vector. Now one thing, my dear friends, you should be very clear with is that when we talk about vector, we are talking about direction, and it is very important to mention the direction, to specify the direction, and that is the reason why in future now onwards, whenever we write a quantity which we want to express it as a vector, we have to differentiate it with some other quantities, and that differentiation is done by putting an arrow over the head of that quantity. For example, when I say force, so how I will write force? I will write, because force is a vector quantity, so it will be expressed with a arrow. Is it clear, my dear friends? So vectors are represented by placing an arrow above the head. Now we are talking about different types of vector, out of which the first type of vector is our what we call as position vector. What we call as position vector. Now, as the name itself suggests that it is a vector which determines the position of an object, or let us say a point, which determines the position or the object of a particular point. That is called a position vector, and with respect to origin, from the origin. For example, I have a you can say Cartesian format along which it is suppose x-axis, it is suppose y-axis, it is z-axis. Obviously this is going to be the origin. Now if I have a point along this place, let us say P. Now from origin, the vector which determines the position of this P, or you can say the distance of this P from origin, it is called a position vector. That means position vector will determine the distance of the point from the origin, and because it is pointing from origin to the point, So it is a vector, and that is a position vector. So how will we write the position vector of P? Position vector of P will be written as OP and shabash and arrow. So this is the definition of position vector. A position vector is that vector which determines the position of a point or an object from the origin. Is it clear, my dear friends? Good. Now the second type of vector which we are going to talk about is called displacement. Is called displacement vector. Now suppose this point P is applied a force F. Suppose the object placed at this point P is applied with a force F, which is having, obviously, let us say the direction this. Let us say the object F is having the force is having the direction F along from you can say left to right. Now it is very obvious that when this force is applied at this point P will shift like this, and ultimately it will reach Q. It will reach Q. Any doubt? So this vector, you can say this length, which determines the displacement or the movement of the body from initial point P to the final point Q, will be termed as displacement vector. That is called displacement vector. It means if I represent the displacement vector, it will be represented by PQ. And as I have told you in the beginning also, okay, my dear friends, whenever we write a vector with arrowhead, it is clear that this P is the initial point and this Q is the final point. That means the body is displaced from P to Q. The body is displaced from P to Q. And when I say QP, it means the body is displaced in the opposite direction from Q to P. Anyhow, any doubt in the displacement vector? So this is what we have to say. And somebody will tell me what is this OQ? What is this OQ? What is this OQ? Shabash? Very good, very good. So OQ is the position vector of Q. Shabash. So OQ is the position vector of Q. So how do we calculate? What are the various laws of vector addition that we are going to discuss in our next lecture? But before we conclude today, is there any doubt? Are you able to understand what are vectors? Are you able to understand the scalar and the vector quantities? Are you able to understand the concept of, you can say, position vector and displacement vector? Is it clear? Now, again, there are some more types of vectors. For example, first of all, again and again we will be revising this, and you have to keep this in mind. Okay, a vector quantity is associated with the direction. So suppose I want to talk about the comparison of various, you can say, vectors. So what do you understand by the term when I say equal vectors? When I say equal vectors, that means if there are two vectors, how you will say that these vectors are equal? If you are given with two vectors A and B, suppose, how you will say that they are equal? Shabash. Very good. So two vectors will be termed as equal when they have same magnitude and they are moving or having same direction. If suppose this is the original point, if suppose a person is running in this direction, another person is running in this direction, if suppose they have let us say the same velocity also, because the component of velocity, that means magnitude, is same and the direction is also same. So this is the example to understand equal vector. It means two vectors will be said to be equal if they have equal magnitude and equal or same direction. Any doubt? Very good. And what about a vector when we say negative vector? What will be the negative of a vector? Negative of a vector. बेटा 5 का नेगेटिव क्या होता है? What is the negative of 5? -5. What is the negative of 10? -10. If suppose you represent 10 from say origin, where will be? ठीक है ना? It will be on the right of 0. Shabash. And when I say -10, it will be on the magnitude is same, but direction is very good. That means the negative of a vector is the vector itself. It is the vector itself having the same magnitude but opposite direction, not different direction, opposite direction. Very good. So fourth, I am talking about the negative vectors. So two vectors are said to be negative if they have same magnitude but opposite directions. Is it clear? Very good. So next type of vector will be, okay, whenever I talk about a vector, obviously a vector when I represent, as I have told you, suppose this is PQ. So obviously, my dear friends, what is P? Good. P is the initial point, the point from where this vector PQ starts. Suppose, I will explain the diagram again. And what is Q? Q is the point where the vector ends. That is called terminus. ठीक है ना? So when I talk about a vector is having, obviously, suppose this is a vector, this. And let us say this is a vector AB. So this is the initial point. That means from where it starts. This is the final point where it is going towards. And suppose I talk about this vector. Suppose I talk about this vector. Suppose I talk about this vector. Try to see the arrow. It means all these vectors, whether I am talking about AB, I am talking about AC, I am talking about, let us say, AD, or let us say AP. All these points are originating, starting from the same initial point, point. So all these vectors will be termed as another type of vector which we call as co-initial vectors. Co-initial vectors. That means co means common and initial means initial point. So when I say co-initial vector, it means all these vectors have a common initial point. Is it clear? ठीक है कि नहीं? Okay. Now suppose if I talk about the different type of vector, let us say BA, let us say CA, let us say DA, and let us say PA. That means all these vectors are ending at A. An ending word in our physics, it is technically called as terminating. Terminating means where it ends. So this is the terminating point. It means all these vectors are terminating at A. So it will be called again one more type of vector, vector number 6. It is called coterminous. Coterminous vector. So all those vectors which have a common initial point, starting point, co-initial, all those vectors which have a common ending point or terminal point is called coterminous vector. And the last but not the least for today is another type of vector which we will be using again and again and again and again and again. Its definition is not so important, but it will be used again and again and again, this particular type of vector, and that is called unit vector. This is called unit vector. That means the unit of the vector? No. What is the meaning of unit? Don't tell me, okay, sir, like centimeter is the unit, meter is the unit. No. In our mathematical format, unity is not that communal unity. When we talk about unit, that is one. That is one. Is it clear? So when I say a unit vector, that means a unit vector is a vector whose magnitude is 1. अब magnitude तो हो गया. What about the direction? Because it is vector. It is a vector. It will have direction also. So I have just now told you the vector which is magnitude, 1. But what about direction? So a unit vector is a vector whose magnitude is 1 and is in the direction of displacement or motion. And it is in the direction of displacement or motion. जिस डायरेक्शन में डिस्प्लेसमेंट होगी उसी डायरेक्शन में एक यूनिट का मैग्नीट्यूड वाला वेक्टर यूनिट वेक्टर कहलाता है. इज देयर एनी डाउट नाउ? आर यू क्लियर विद ऑल दीज बेसिक फंडामेंट्स? So I think that is more than sufficient for today. So these are certain basic concepts of vector. So my dear friends, keep revising, and whenever you have a doubt, most welcome to us. We are always there to help you, and I hope I was audible, I was able to reach the mind of all of you. And till our next lecture, do take care of yourself, stay safe, and all the very best. Thank you very much.